Chapter 8, Section 3, Activity Series of Elements. So what is an activity series? It's a list of of elements organized according to their reactivity. So activity series is a list of elements organized according to their reactivity. Reactivity means ability for elements to undergo certain chemical reactions. So ability for elements to undergo certain chemical reactions. So here some elements react with water, with hydrochloric acid, with oxygen, but another elements do not react with water, or do not react with oxygen, or do not react with hydrochloric acid, with acids. So why? It depends on what? It depends on the reactivity of elements. So you have to know the list or the activity series for metals. So the most reactive element at the top of the series, here potassium, sodium, calcium, magnesium, aluminum, iron, hydrogen, and copper. So here you have to know element at the top of the series is the most reactive element, and element at the bottom of the series is the least reactive element. So here in this direction, reactivity for elements increases, and in this direction reactivity of elements decreases. So this is the reactivity series for metals. At the top, the most reactive element, so here potassium is the most reactive element, and copper is the least reactive element. For non-metal, exactly for halogens, here fluorine, chlorine, bromine, and iodine. Fluorine at the top of the reactivity series, at the top of the list, so it's the most reactive element, and iodine is the least reactive halogens in the series. So here in this direction reactivity increases, and in this direction reactivity decreases. So here fluorine is the most reactive halogen, and iodine the least reactive halogen. So an activity series helps determine what element will displace other in a chemical reaction, and whether a chemical reaction will occur or not. How? Here you have to know that element can replaces all elements below it but not above it. For example, Potassium can replace sodium in a compound, or calcium, magnesium, aluminum, iron, or hydrogen from water or acid, or copper. So for example, magnesium. Magnesium can replace aluminum, iron, hydrogen from water or acid, and copper, but can't replaces calcium, sodium, and potassium. For example here, copper. Copper can't replaces hydrogen from water or acid. So copper can't react with water or with hydrochloric acid. But potassium, sodium, calcium, magnesium, aluminum, iron can replaces hydrogen from acid. So these elements can react with acids, but copper can't react with acid. Why? Because the reactivity of copper less than hydrogen, so it can't replaces hydrogen. The same for group 7 in the periodic table, halogens. Fluorine is the most reactive halogen, and iodine is the least reactive halogen. So fluorine can replaces chlorine, bromine, and iodine. But for example, iodine can't replaces bromine or chlorine or fluorine. So the rule is the most reactive element placed at the top in the series, and it can replace each of the elements below it. So again, the most reactive element at the top of the series, and can replace all elements below it, and not the reverse. Can't replaces any element above it. So if you remember from a single displacement reaction, the rule is element replaces similar element in a compound. Here you have to add this rule: element replaces the more reactive element replaces the less reactive element. So in single displacement reactions, element replaces similar element, but you have to know that the more reactive element replaces the less reactive element, and not the reverse. An example: sodium plus iron oxide. So will the reaction occur or not? It's a single displacement reactions, element plus compound. So the rule is element replaces similar elements. Sodium is a metal, will replaces iron, because metal and iron metal. But you have to ask yourself, is sodium is more reactive than iron, so it can replaces it, you have to use the reactivity series. Sodium is more reactive than iron, so it can replaces iron. So the reaction occur. So here the products are, instead of iron oxide, sodium oxide and iron. So to balance this equation here, you have to add 2 before sodium. So again, this is a single displacement reaction. The rule is element replaces similar element in the compound. So here sodium replaces iron. But not all single displacement reactions occur, because single displacement reactions depends on the reactivity of metals. The rule is the more reactive element replaces the less reactive element in the compound, and not the reverse. So for example, iron plus sodium oxide, it's a single displacement reaction, element plus compound, and here iron is a metal and sodium is a metal. So element replaces similar element, but this reaction occur or not. Single displacement reaction depends on the reactivity. Is iron is more reactive than sodium? Here iron is more reactive than sodium? No. Iron can replaces hydrogen and copper, but can't replaces elements above it. So here iron can't replaces sodium. So here iron can't replaces sodium. So no reaction occur. Another example for halogens. Fluorine plus potassium bromide. It's a single displacement reaction, element plus compound. And here fluorine is a nonmetal and bromine is a nonmetal. So fluorine replaces bromine. But fluorine is more reactive than bromine. You have to use the reactivity series. Yes, fluorine is more reactive than bromine, so can replace bromine. So this reaction occur, and the products are, instead of potassium bromide, potassium fluoride and bromine. Then you have to balance the equation here and here, 2 potassium and 2 potassium, 2 fluorine, 2 fluorine. Now what about the reverse? Bromine plus potassium fluoride. It's a single displacement reaction, and bromine is a nonmetal, fluoride is a nonmetal. So bromine replaces fluoride, but bromine is more reactive than fluorine. Bromine can replaces fluorine? No, can't replaces fluorine. So this reaction does not occur. So again, activity series is a list of elements organized according to their reactivity. These are the list for metal and halogens. You have to know from this list that the most reactive element at the top of the series and the least reactive element at the bottom of the series, and the most reactive element can replaces all elements below it. and here the most reactive halogen can replaces all elements below it. For example, magnesium can replaces aluminum, iron, hydrogen in water or acid, and copper, but can't replaces any element above it. So you have to use this series to predict whether a reaction in single displacement reaction occur or not. So in single displacement reaction, as in section 2, elements replaces similar element, but now you have to know that this rule satisfies when the element is most reactive than element in the compound. So here is the rule. The more reactive element replaces the less reactive element in the compound. Another examples here. Based on the activity series, predict whether each of the following possible reaction will occur. So here, magnesium plus sulfuric acid. Magnesium is a metal, carry positive charge, and here hydrogen positive and sulfate carry negative charge. So here element replaces similar element. So magnesium replaces hydrogen, but magnesium is more reactive than hydrogen. So what about the series? Magnesium is more reactive than hydrogen, so can replaces hydrogen, so the reaction occur. What are the products? Instead of sulfuric acid, hydrogen with sulfate group, magnesium with sulfate group, and hydrogen gas. Now what about the second one? It's a single displacement reaction, metal plus compound. All the reactions are single displacement reactions, metals plus compound. Now, copper is a metal, carry positive charge, and hydrogen in hydrochloric acid carry positive charge and chloride negative charge. So copper replaces similar elements, but copper is more reactive than hydrogen. Copper is more reactive than hydrogen? No. Copper can't replaces hydrogen because hydrogen more reactive than copper, and the rule is the more reactive can replaces the less reactive element, not the reverse. So here no reaction occur. Now what about the third one? Bromine plus potassium iodide. So according to the series, bromine is more reactive than iodine, so the reaction occur. What are the products? Instead of potassium iodide, potassium bromide and iodine. Now what about the fourth one? Chlorine plus sodium fluoride. So here it's a halogen, here metal, and here halogen. So chlorine can replaces fluorine. What about the series? Chlorine can replaces fluorine? No. So no reaction occur. Now here aluminum is a metal, magnesium is a metal, and it's a polyatomic ion. Here it's in group 3 and here 2. So aluminum element replaces similar elements. Aluminum is more reactive than magnesium. Aluminum more reactive than magnesium? No. So aluminum can replaces magnesium? No. So here no reaction occur. The last example, iron plus calcium chloride. Iron is a metal and calcium is a metal and chloride is a halogen. Now element replaces similar element, but iron is more reactive than calcium. Iron is more reactive than calcium? No, less reactive. So iron can replaces calcium in a compound? No. So here no reaction occur. So again, for single displacement reactions, you have to use the reactivity series to predict whether a reaction occurred or not. And you have to memorize this series in the exam. You have to know that the most reactive element at the top, and any element can replaces all elements below it in the series but not above it. Thank you.